This is the current electricity topic. This section, 8.4, is about electron volts, a tiny, tiny, tiny unit of energy. An electron volt is a tiny, tiny unit of energy. Definition for an electron volt is the amount of energy possessed by a single electron as it leaves a 1-volt battery. What's important here? 1 electron, 1 volt. You can also think of it, instead of the amount of energy being gained by that electron, you can think of it as the amount of energy dissipated or used up, converted to heat, when a single electron passes through a component, a resistor, a light bulb, whatever, right, with a 1-volt potential difference. Again, 1 electron, 1 volt. 1 electron volt. Now remember, the electron volt, abbreviated EV, right, 1 electron volt, is a unit of energy, and a joule is also a unit of energy. The electron volt is much, much smaller than a joule. 1 electron volt is actually equal to 1.6 times 10 to the negative 19 joules. So what would that be in decimal form? Well, in decimal form, 1 electron volt would be equal to, let's see, 0.0000, that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, oh my goodness, almost running off the board there. Okay, so 1 electron volt is equal to a tiny, tiny fraction of a joule. Okay, very, very small. An electron volt is very, very small. Now, what if we wanted to figure out how many electron volts would be equal to 1 joule? We would do some math. All right? If you start with an equality that you know to be correct, such as this one, and you perform correct math on that equality, then the equality that you get will also be correct. I'd like to know how many electron volts are in 1 joule. So I want the number 1 to be here. So I'm going to divide, and whatever you do, you have to do to both sides. I'm going to divide both sides by 1.6 times 10 to the negative 19. And if you do that, 0.6 times 10 to the negative 19, take 1 divided by 1.6 times 10 to the negative 19, you're going to get 6.25 times 10 to the 18th on this side, that's electron volts, right, is equal to, this divided by this cancels, and you have 1 joule. So the electron volt is so small that there's this many of them in 1 joule. Right, that's a big number. Remember, the electron volt was so tiny compared to the joule that there are a lot of them equal to 1 joule. Given that we know that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules, now remember, this is the equality that is on your reference tables. And we also know that 6.25 times 10 to the 18th electron volts is equal to 1 joule. We figured this equality out based upon this one. We can use either of these equalities, it doesn't matter, to convert electron volts to joules or joules to electron volts. Let's do that now for practice. So now that we have 2 different equalities, we can have 2 different ways to convert from electron volts to joules and vice versa. Now, the way that you'll probably do it is to say that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. Because you don't have to memorize that, it's right on your reference tables. Now, this is the factor label method. You can tell because we want to convert 6 electron volts. All right, so we put a big giant set of parentheses and a line through the middle to show division. Now, I want to get rid of electron volts, so I put electron volts on the bottom. I want joules, so I put the joules on top. Electron volts, top and bottom, are going to cancel. Always put the units first, then put the correct numbers next to the units so that whatever is inside the parentheses equals each other. We know that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. So now let's do the multiplication. 6 electron volts all right, times 1.6 times 10 to the negative 19, all right, is 9.6 times 10 to the negative 19 joules. Now, what's also correct, all right, electron volts, joules, is that in 1 joule, there are 6.25 times 10 to the 18th electron volts. So if you take the 6 and divide by this number, let's do that. 6 divided by 6.25 times 10 to the 18th. Right? We also get, as we would hope, the same correct answer, 9.6 times 10 to the negative 19 joules. All right, so you can do it this way or you can do it that way. It doesn't matter. You're probably going to do it this way because this is the equality that is in your reference tables. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules, right on the front of your reference tables. What if we have joules and we want to convert to electron volts? Well, we'd like to get rid of the joules, so put joules on the bottom, put electron volts on top. The joules are going to cancel. We still need two things that equal each other here. We know that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. Inside the parentheses have to equal each other. Now remember, you never cross multiply because the equal sign is over here. You don't cross multiply when you're doing factor-Legel method. All right, so 1.28 times 10 to the negative 16 divided by 1.6 times 10 to the negative 19 equals 800 electron volts. This is on the bottom, so it's this number divided by that number. Now down here, all right, joules, electron volts. All right, keep in mind that 1 joule, right, is 6.25 times 10 to the 18th electron volts. So now let's multiply this number by that number and see what we get. 1.28 times 10 to the negative 16 times 6.25 times 10 to the 18th. And we get, imagine that, 800, all right, electron volts. Okay, so we're not going to have any trouble converting electron volts to joules. And again, remember that this one, 1 electron volt equals 1.6 times 10 to the negative 19 joules, is right on the front of your reference tables. Now, there's a wonderful little trick to modifying the voltage/electrical energy work equation to calculate electron volts directly. And let's start by writing down the equation for the definition of voltage. All right, we know that voltage, or potential difference, is equal to work, all right, divided by charge. All right, so that's the equation that defines voltage. It's the work per unit charge, or the amount of electrical energy per unit charge. Now, if you rearrange this equation to get the W by itself, right, put the V over 1, cross multiply, then we get W equals, all right, Q times V. We cross multiply. So here's the equation, the same equation, rearranged to solve for W. All right, W equals Q times V. Now, we know that W, all right, is work. A synonym, all right, a phrase that is synonymous with the word work would be electrical energy. We know that the Q is charge, and we know that the V is voltage, potential difference, potential drop, etc. Now, focus on the units. If you plug in for charge, if you plug in the unit coulomb, all right, or capital C, and you plug in volts for voltage, all right, capital V, then the unit you will get for work is the joule. If you plug in coulombs and volts, you will get joules. All right, now, keep in mind that volts, all right, are really joules per coulomb. All right, we'll bring that up again later. All right, so you're going to see that the coulombs and these coulombs are going to cancel. So one way or the other, you're going to get joules. All right, if you put in coulombs and volts, you get joules. Right? If you put in joules, you get coulombs, okay, and volts. All right. Now let's look at the electron volt version, where instead of getting joules for electrical energy, we will get electron volts directly. So here's the version of that same equation that gives us electron volts directly. All right, W, which is work or electrical energy, is equal to N, that's a certain number of electrons, 5 electrons, 10 electrons, 67,000 electrons, right, times the voltage. So what would this be now? All right, work, electrical energy would be the same. This is work or electrical energy. Instead of charge, this is a certain number of electrons. Now it's easy to see that the number of electrons comes from the charge anyway. We can easily convert back and forth between number of electrons and charge anyway. But if you put in the number of electrons, 1 electron, 5 electrons, 83,000 electrons, right? And this would be voltage. Okay, now the units, all right, this would just be electrons. All right, let's say it was 3 electrons. All right, the volts may be 10 volts, okay, whatever. Now the unit you're going to get over here is not joules. You're going to get the unit electron volts. This particular problem, you would have 30 electron volts. 3 electrons, right, passing through a potential difference of 10 volts, they now possess 30 electron volts. Right? Or perhaps they gave 30 electron volts of energy to a resistor or a light bulb. Okay? So you can think of this as a different version of W equals Q times V. This is W equals N times V. The other equation gives us joules. Here, when you put in the number of electrons instead of coulombs, you get electron volts directly. All right, now let's see how the two different versions of the equation can be used. Calculate the amount of energy dissipated, basically converted to heat inside of a resistor, when 3 electrons pass through and the voltage across that resistor is 6 volts. Now, the first thing I'd like to do, I'd like to remind you that 3 electrons carry a certain amount of charge. All right, so 3 electrons, all right. The point was a little ridiculous. You can't have half an electron, so let's just say 3 electrons. Okay, 3 electrons, and I'd like to convert that to charge or coulombs. Well, 1 electron, right, has a charge of negative 1.6 times 10 to the negative 19 coulombs. All right, so the electrons cancel, and 3 times 1.6, all right, is going to give us negative 4.8 times 10 to the negative 19 coulombs. All right, so that's the charge. This is N, the number of electrons. That is Q, the charge on those electrons. So I can use either equation at this point because I have all the information I need to use this equation. W equals Q times V. I have V, I have Q. Or I have all the information I need to use this version of the equation. W equals N times V. Right? It all depends on whether you're looking to get joules, or you're looking to get, electron volts, or you're looking to get joules. This equation will give you electron volts. This equation will give you joules. All right? So, let's do both versions. Okay? Or actually, let's do one version, and then let's convert electron volts to joules. All right, so let's do W equals Q times V first. All right, the charge on the 3 electrons was 4.8, actually it's negative 4.8, times 10 to the negative 19 coulombs. Now, volts, all right, we had 6 volts, all right, and that would be 6. A volt is a joule per coulomb. all right? So we're going to multiply 4.8 times 10 to the negative 19 times 6 volts. Okay, 4.8 times 10 to the negative 19 times 6. All right, so we're getting, all right, 2.88 times 10 to the negative 18. All right, the coulombs cancel, and we've got joules. I'm not sure that the negative is terribly important here. All right, so the energy possessed by those 3 electrons is 2.88 times 10 to the negative 18 joules. Now, how many electron volts would that be? Well, take 2.88 times 10 to the negative 18 joules. We're going to use the factor label method to convert this to electron volts. Joules on top, joules on the bottom. I'm getting rid of joules. I want electron volts. Joules are going to cancel. These two numbers must equal each other. We know that 1 electron volt is 1.6 times 10 to the negative 19 coulombs. Joules. 1 electron volt, 1.6 times 10 to the negative 19 joules. Right? So we take this number, divide by that number. 2.88, all right, divided by 1.6 second e negative 19. All right, and we've got 18, all right, 18 electron volts. Okay, now, how could we have gotten electron volts directly? We would use the other version of this equation that has the n in it, the number of electrons. Now remember, we're supposed to be getting 18 electron volts. Let's see how we do here. Okay, so the other version, the energy, the electrical energy is equal to the number of electrons times the volts. Well, we had 3 electrons, all right, and we had 6 volts. So what do we get when we multiply those two together? We get 18 electron volts, EV. All right, the energy is 18 electron volts. So you see, very simple to convert number of electrons to charge, right? Number of electrons to coulombs, that is, all right? Very easy to convert electron volts to joules, joules to electron volts. Okay, very, very simple. Depends what they're asking for. If they want joules, then perhaps you want to use the equation W equals Q times V. If they want electron volts, then perhaps you want to use this version, all right, W equals N times V. If they give you coulombs up here and you want electron volts, change your coulombs to electrons before you start, and vice versa. If they give you the number of electrons, but they want joules, change those electrons to coulombs before you start. Remember, here, this is what you really, really want to remember, okay? W equals Q times V. If you put in coulombs, all right, and volts, you're going to get joules. All right, if you put in the number of electrons, right, and volts, okay, logically you're going to get electron volts. Okay?